By 2030, electric vehicles are expected to account for 35 to 40% of total new car sales. While it's undeniable that electric vehicles are currently more expensive than their fossil fuel counterparts, this price difference is expected to decrease as the cost of components, particularly batteries, goes down. Another key factor that can help reduce production costs for all vehicles, especially electric ones, is the advanced integration of robots in manufacturing. Tesla, a pioneer in this field, Robot Optimus with AI-5 software, upgraded tenfold compared to the previous hardware, will play an important role. How will the Tesla Bot Gen 3 participate in the production of batteries for Tesla's Model 2? What key enhancements has Elon Musk committed to implementing for Optimus prior to its 2025 market debut? At the annual shareholder meeting, Elon Musk confidently predicted that the majority of Tesla's long-term value would come from Optimus, and he's very confident in that prediction. Top experts estimate Tesla's valuation to be over $5 trillion based solely on the self-driving capability of its vehicles, excluding Optimus. That's quite accurate, but it becomes even more mind-blowing when you think about the Optimus robot, which is essentially a humanoid robot designed to do anything you want. It can be your companion, it can be in your home, it can babysit your kids, it can teach, it can be an excellent teacher, and it can do factory work. Ultimately, how many super helpful humanoid drones would you want? Who wouldn't want a C-3PO? With C-3PO plus R2-D2 plus, it'd be pretty amazing. I bet everybody in the world would want one, literally everyone. And then there'd obviously be robots in the industry, making everything. Musk also suggested that the ratio of humanoid robots to humans would probably be at least 2 to 1, something like that, certainly 1 to 1. This means that around 10 billion humanoid robots, possibly 20 or 30 billion of them. And if Tesla only has 10% of that market, it could be more than 10%. Musk could probably produce around 100 million Optimus robots every year. Because of the large quantity, they would create a robot at a very high-scale cost of around $10,000. It'd be cheaper than a car, and if we think Musk sells it for $20,000, Tesla would basically earn about $1 trillion in profit each year from that. If the price-to-earnings ratio is below 20 or 25, something like that, it means that Optimus alone would have a market capitalization of $20 trillion, and possibly another 5 to 10 trillion from self-driving cars. So as we see it, it's entirely conceivable that Tesla could achieve a valuation 10 times that of the most valuable company today. That seems to be why Musk is so focused on AI. Additionally, Tesla will ensure that these robots behave well and act appropriately while working, which is pretty important. Tesla is also a leader in real-world AI. Tesla's ahead of Google, Meta, anyone in real-world software, and it's getting better, I'd say, with each passing month, if not each week. Notably, Tesla is quite skilled in chip design, so the AI interference chips designed by Tesla for cars have AI Hardware 3, and cars produced in the past year have Hardware 4. They just completed the design on Hardware 5, and now they're moving on to AI 5. In chip design, it's like starting from scratch in AI software and having the best real-world AI software and the best AI inference chips in the world from nothing. This is a major issue requiring extremely important research for Optimus. Hardware 4 runs Hardware 3 in simulation mode. Therefore, significant progress will continue to be made on Hardware 3, but by the end of this year, work will really split, continuing on Hardware 3, training on Hardware 3, but then conducting separate training on Hardware 4, which will be the type of training cluster being built on the south side of the Gigafactory. With Hardware 4, the cameras have about 4 to 5 times better resolution, and depending on how you count, Hardware 4 is about 3 to 8 times better than Hardware 3. But everything you've seen so far is just Hardware 3, and we still have a long way to go before reaching the limits of Hardware 3. So we believe Hardware 3 will still achieve amazing things, but I think Hardware 4 will likely be about 5 times better. Then Hardware 5 coming out in about 18 months will be 10 times better than Hardware 4. Therefore, what Tesla will gradually do is improve the reliability that the car achieves, and then of course, this will also be incorporated into Optimus. The same chip going into Hardware 4 will be put into Optimus. Hardware 5 transition into AI 5 will be in Optimus in all the cars in about 18 months. Elon Musk is very proud of his humanoid robot, which is actually performing useful tasks in the factory right now. Currently, there are 2 Optimus robots in the Fremont factory essentially performing this task, taking cells off the line and placing them into shipping containers. In the near future, they're expected to participate in the production of new generation cars, possibly the $25,000 Model 2. With the previous plan to move limited production of Optimus next year, limited production for use in our factories where we will test the product. But I think next year, my prediction is that they'll have over 1,000, maybe a few thousand Optimus robots working at Tesla. And everything will scale up very quickly from there. So it'll help Tesla address any issues detected with Optimus. The level of autonomy will improve drastically. Literally, you'll be able to talk to it, say, do this task, or I will show you something. Now do what I'm showing you. Promisingly, this will reach a level where it can watch a video of something, such as a person, then learn just by watching that video, and then perform the task. So it's going to make a really big splash when it hits the market next year. You're seeing a lot of startups in robotics, but we think executing Optimus as a robotics startup is quite challenging. Because what we found is, to make Optimus work, you have to design everything from first principles, from scratch, every part of the robot. So the motors, gearbox, sensors, power electronics, communication systems, everything has to be designed from the ground up. So even though there are many electric motors manufactured worldwide, there's no supply chain for these types of motors, sensors, and gearboxes that's needed for humanoid robots. What you're seeing here is our current generation, a hand and arm with 11 degrees of freedom. Our next generation will have 22 degrees of freedom. It'll be able to play the piano. Of course, we need to ensure that we don't encounter a Terminator scenario. That's crucial. So the safety of humanoid robots is going to be very important. But because it requires so much foundational design, designing every motor, gearbox, sensor, power electronics from scratch, it's very difficult for a startup, if not impossible, to mimic that. But at Tesla, they have the world's best engineering technology. They have the world's best mechanical engineering for gearboxes and electric motors and power electronics. So they have the resources to do that, and it's applied quite well. And then, of course, there needs to be a brain. It requires an energy-efficient inference computer that's already equipped for cars and will be used in Optimus. And then expertise in large-scale manufacturing is also required. Therefore, to create a robot that doesn't cost hundreds of thousands of dollars, to make it priced around $10,000 to $20,000, it really needs to be designed for efficient production and manufacturing. Elon Musk has previously mentioned that prototyping is relatively easy compared to mass production. Roughly speaking, prototyping is easy, production is hard. Tesla has manufacturing capability, technical expertise, and artificial intelligence in both hardware and software. Tesla's CEO addressed questions about integrating Tesla Optimus into various industries and its potential capabilities. He envisioned a future where the Optimus robot would be widely used, customizable, and able to learn user preferences. You'll be able to customize its personality, customize its voice, and truly the robot will get to know you and learn your preferences. You won't even have much to say because it'll understand you. Musk discussed the necessity of specific training programs for tasks and the development towards broader adaptability by 2026. This process aims to enable Optimus to efficiently perform diverse tasks, reflecting advancements in integrating robots across different fields. How does Tesla Optimus' involvement in the battery production for the Model 2 contribute to improving quality? Integrating Tesla Optimus into the battery production process and various components for the Model 2 electric vehicle promises significant benefits in manufacturing efficiency and potentially revolutionizing the EV industry. First, how would Gen 3 contribute to assembling the Model 2 batteries? Optimus can use its flexible robotic arms to install battery cells into casings, connect electronic components, and seal batteries with adhesive or welding. Its precision handling capabilities enable it to perform tasks more accurately and consistently than humans, thereby improving battery quality and reducing errors. Additionally, Optimus is equipped with 2D cameras and advanced sensors to automatically inspect batteries, including visual checks, examining cells for defects or damage, and assessing battery performance. Optimus can detect minor flaws that humans might overlook, thereby enhancing battery quality and reducing defective product rates. For transportation and energy, Tesla's robots can utilize robotic arms and integrated forklifts to safely and efficiently move batteries within the factory from one area to another. Optimus can lift and transport heavy batteries easily, minimizing the risk of accidents for workers and improving transportation efficiency. Moreover, Optimus will also handle battery recycling. It can use robotic arms and specialized tools to dismantle batteries, recover valuable materials such as lithium, cobalt, nickel, and then sort them for recycling. Optimus can safely and efficiently disassemble batteries, helping reduce environmental pollution and conserve resources. Integrating Tesla Optimus into the Model 2 battery production process significantly enhances productivity and product quantity. It increases productivity by up to 25% and reduces direct labor costs by up to 15%. Optimus can operate continuously 24/7 without rest, helping maintain uninterrupted production processes. This surpasses manual labor, typically operating in 8-hour shifts with breaks. Moreover, Optimus can operate in harsher environments where humans might find it challenging. Think high temperatures or hazardous chemical environments. Furthermore, Optimus can be utilized for other tasks in the battery production process, such as equipment maintenance, factory cleaning, and data collection. Using Optimus for these tasks can improve accuracy, efficiency, and safety in the battery production process, while reducing costs and waste. For other components of the Model 2 electric vehicle, does Optimus participate? Certainly, it can efficiently support manufacturing, ensuring optimal quantity and quality. Optimus can assist in welding, assembly, and finishing the vehicle frame, including tasks like welding steel bars, installing suspension parts, and steering systems. Gen 3 can perform welding processes more accurately and consistently than humans, thereby enhancing frame quality and minimizing errors. Optimus's enhanced capabilities allow it to handle large and heavy frame components with ease, improving efficiency and reducing the risk of accidents for workers. Optimus can also support stamping, welding, and assembling car body panels, including tasks such as stamping metal sheets, welding joints, and installing doors. Optimus can execute tasks with high precision, improving body panel quality and reducing errors. Its sophisticated handling capabilities enable it to perform complex operations like welding narrow joints or installing smaller exterior parts. Regarding the drivetrain system, Optimus can support assembling drivetrain components, including engines, gearboxes, and drive shafts. Optimus can perform assembly operations more accurately and efficiently than humans, enhancing the quality of the drivetrain system and reducing noise and vibrations. Optimus can operate in enclosed or dirty environments where humans find it difficult to work. Optimus is designed with significantly higher precision and reliability compared to manual labor. The robot's sensors and control systems ensure all operations are performed with absolute accuracy, minimizing errors and enhancing product quality. For instance, a study by the Massachusetts Institute of Technology, that's MIT, demonstrated that robots can reduce production defects to below 1% compared to the average human error rate, which ranges from 5 to 10%. Additionally, Optimus can perform automated quality checks, detecting potential flaws that human eyes might overlook. Production speed is also greatly improved due to Optimus's ability to operate tools and execute assembly tasks quickly and synchronously. Automating manufacturing processes optimizes workflows, reduces wait time between stages, and increases production speeds. According to a report by the International Productivity and Creativity Organization, IPC, automation can boost production speeds by up to 30%. Unreal. While the initial investment costs for deploying Optimus robots may be high, in the long run, it reduces direct labor costs and maintenance expenses while improving cost efficiency. Estimates suggest that robot maintenance costs are typically under 20% compared to managing and maintaining human staff. Optimus is also integrated with advanced technologies such as artificial intelligence, AI, machine learning, and modern sensors, optimizing production processes and early detecting manufacturing defects. These factors not only help Tesla increase productivity but also ensure product quality remains consistently high. Integrating Optimus into the Model 2 battery production process is indeed a significant step forward in improving and modernizing industrial manufacturing processes. In Tesla's factory, workers can guide robots by recording actions that robots will then replicate. Optimus can be taught to handle repetitive and mundane tasks, relieving humans from performing them. Tesla's robots also automatically pause when humans are nearby. In addition, combined with another enhancement, autonomous mobile robots, AMRs, these can enhance efficiency by navigating dynamic and complex environments both inside and outside. AMRs facilitate convenient movement of parts around the factory floor among production areas. Looking at the advantages of using Gen 3 bots in the battery industry to produce affordable vehicles. Handling large and heavy tray assemblies, automating with robots is the most logical solution due to their capability to manage such sizable components. Some battery trays for vehicles can be as large as 6 by 8 feet and weigh nearly 300 pounds. The weight, size, and precise positioning requirements of these parts make robotic use a smart choice. Complex processes cannot be overlooked. From moving heavy blanks or applying adhesive for a tray assembly to metal drilling, manufacturing battery tray assemblies involve multiple stages, including gas metal arc welding or GMAW and resistance spot welding, also known as RSW. Widely favored by automotive manufacturers for lightweighting, reducing vehicle part weight to improve fuel efficiency, the use of aluminum alloys is driving demand for alternative welding methods such as self-piercing rivets like henrob, fixed and remote laser welding, as well as hybrid laser welding. Depending on the assembly tray design, i.e. casting design, Optimus's involvement and coordination with large robotic arms may also be necessary. However, most would agree that the presence of Gen 3 in the factory is significantly enhancing workplace safety compared to previous applications that listed current risks and potential harm to humans. From lifting heavy parts and repetitive tasks to inhaling hazardous fumes during adhesive distribution, you should utilize robots for these potentially dangerous activities. As an additional benefit, Tesla's robotic automation for these tasks can free up humans to perform higher value-added activities such as path programming, quality inspection, or technical support. The anticipated release of new Tesla products in 2025 featuring the Optimus Gen 3 robot in the Model 2 marks a pivotal moment in technology. Optimus Gen 3 will not only revolutionize automation but also plays a crucial role in the production of the affordable and innovative Model 2. This synergy is set to redefine both industries, making advanced technology more accessible and setting new standards for convenience and efficiency. Tesla's breakthroughs in robotics and electric cars are poised to make 2025 a landmark year for technological progress. We hope you will experience the utmost relaxation after watching this video. If you do, please press the like button and join the Tesla Car World community by subscribing to our channel. Hit the notification bell icon to stay tuned for any fantastic videos coming your way. Your feedback and time are highly appreciated. Thanks so much for watching, and we look forward to seeing you soon. Until then, stay safe and enjoy.